Hey everyone, let's look at the concept of production functions in this section. So, what is production? Production is the process a firm uses to convert inputs to output or the final product it wishes to sell. In this picture, the output is the pizza and the input can be workers, the oven, and the ingredients that goes in the production of the pizza, as for example the cheese, the dough, the veggies, and whatever else that goes into the production of the pizza. Alrighty, now let's go and look at the short run and the long run. So it says short run, we have some variable inputs and the fixed plant. That means we have some fixed input and we have some variable inputs. So variable input is something that can be increased or decreased in a short period of time. And fixed inputs cannot be changed in the short run. So labor, this is an example of variable input. One example of short run is Macy's hiring more workers before Christmas. Now we can look at the long run, and unlike the short run, all inputs are variable in the long run. It says the firms can adjust plant size and they can enter and exit the industry. So if Macy's plan to open up new stores in different locations, that's an example of the long run. That's a long run decision making on the part of Macy's. Okay, that's the difference between the short run and the long run. Now take a look at this slide here. I have this picture and all these pictures are from Open Economic Resources. So here we have two lumberjacks and this is a 2-person saw. This is cutting trees. So my variable input here is labor and this is my output. So the output is also defined as total product and that is abbreviated as TP. If one worker is hired, the total output is 0. That means nothing is being produced. Alright, so nothing surprising there. If we have one worker can cut 4 trees. So total output is 4. If we have two workers can cut 10 trees. So 10 is my total output. Now if we have 3 workers, the total output is 12. Next, after we did the total output, we can look at the concept of marginal product. So this is equal to change in total output over change in labor. So this sign delta is for change. Now the marginal product of the first worker is 4 minus 0. That means difference in output between the first worker and the 0 worker over 1 minus 0. This is equal to 4. The marginal productivity of the second worker is 10 minus 4 over 2 minus 1. This is equal to 6. Marginal productivity of the third worker is 12 minus 10 over 3 minus 2. This is equal to 2. So this calculation is very much straightforward. And as we can see here, the marginal product goes down after the second worker is hired. And this is called the concept of diminishing marginal product. And why this goes down? This is something we will explain in the next slide. Now let's look at the definition or the formula for average product. So average product is measuring the productivity of workers, and this is defined as total product over the number of workers or labor. For the first worker, average product is 4 over 1. This equals to 4. For the second worker, this is 10 over 2. That equals 5. For the third worker is 12 over 3, and that equals 4. Now this slide just shows us the formula of marginal product and average product. That is something we went over using the picture in this slide, the slide before. And definitely the total product is the total output that is being produced. Now we talked about the concept of diminishing returns. So take a look at this numbers here. Looks like the marginal product goes down after some point. And why is that? So we have to remember that we are in the short run, and in the short run the only variable resource is labor and everything else is fixed. So it's like we are adding more and more variable resource to the fixed quantity of I would say more variable resource to some fixed resource. That means we are not increasing the number of sawmills here, and we keep on adding more workers, but we are not increasing the plant size. So this is fixed, and we keep on adding the variable resource, which is workers. So because of that, the marginal product will fall. So something else we can say here, marginal product will fall. So we can say that the total product increases at a decreasing rate. So going back to our simple example here, looks like the total product is increasing from 4 to 10 and then from 10 to 12. So here the rate of increase from 10 to 12. So this is going down compared to the rate of increase from 4 to 10. All because labor is the only variable input of production and capital or plant size is fixed. Now extending our example here, take a look at this table. The first column we have the number of labor hired, which goes up from 0, 1 to 8. Then second column we have the total product or output. Third column we have marginal product, and column 4 we have average product. So the calculation is pretty much straightforward. So the total product for the first worker is 10. The marginal product is 10. So how did we calculate this? 10 minus 0 over 1 minus 0. For the second worker, this is 25 minus 10 over 2 minus 1. This is equal to 15. And I can use the same calculation for all successive units of workers hired. Now the average product for the first worker is 10 over 1. For the second worker is 25 over 2. Now from the first worker to worker number 3, looks like my marginal product. This marginal product is increasing. We have increasing marginal returns. After that, from worker number 4 to worker number 7, the marginal product is decreasing and we have diminishing marginal returns. And from worker number 7 to worker number 8, we have negative marginal product. That means the total product is decreasing. So something to note here, as you can see here, the total product keeps increasing except for worker number 8. So when the total product keeps increasing at an increasing rate, so from here the marginal product is increasing. Now here the total product is increasing but at a decreasing rate. Keep in mind we are in the short run where capital is fixed and labor is the only variable input in the production process, and marginal product is going down here. Now when total product is at its max, the marginal product is equal to 0. Okay. Now when total product keeps decreasing, down arrow is for decrease, up arrow is for increase, this marginal product is a negative number. So one of the questions that we have, I probably in the homework, so this marginal product can either be positive or it can be 0 or it can be negative. Everything is possible. So the next slide, I'm gonna look at everything graphically, like graphing out everything that we learned so far. I have the workers or labor in the horizontal axis and I have the production functions on the vertical axis. So on this one, as you can see, I have this total product graph. Looks like this keeps increasing here. This is my total product graph. So this is increasing, then this is reaching a maximum, then this keeps going down. And as you can see here, this marginal product, this is increasing, then this keeps going down. We have diminishing marginal returns. Whenever the total product is maximum, marginal product is equal to 0. And whenever total product goes down, this marginal product is a negative number. The last thing to note here is, looks like marginal product is cutting the average product at some point. So coming back here, so this marginal product is cutting the average product here, where the average product is at its maximum value. Let me just write it down here. Marginal product is equal to average product when this average product is at its max value. All right, that's